I think I'm sharing my screen now. Let us go live. And then, unfortunately, it's like it just started. Here we go. Okay, so welcome back to everybody who did a engineering and entertainment last time. We are on another episode today. So we are doing light and kaleidoscopes. Did I do anything fascinating, Nathan? Thank you for asking. No, not really. Learning how to skateboard, I guess, if that counts, but no, that's it. Thank you. I didn't want that to go unnoticed. So today we are doing light and kaleidoscopes for our engineering and entertainment episode 2. Yeah, I got that right. Okay. If you remember me, I'm Nathan. If not, that's okay. I'm studying software engineering, and I am an engineering outreach program instructor for engineering outreach, of course. There's our little socials on the bottom left there. And my partner, Nicole.
Hi everyone, my name is Nicole. I did a degree in biomedical engineering, and I'm going to be an engineering outreach program instructor, but I'm also a program coordinator.
That basically means that he's my boss. Thanks, Nicole. We're going to go into our quick code of conduct. Remember, we joined the Zoom session with our names so that we can tell everyone apart. Microphones and cameras remain off for your safety and privacy. If you want to turn them on, feel free, but remember that it is being live streamed, it is being recorded. So there'll be some time at the end where I'll turn all that off and you can ask me any of the questions you want on your mic if you don't want to be live streamed or recorded. Chat function, keep it relevant and respect everyone. I'm sure we remember the rules. Our disclaimer once again, as I just said, so recorded, live streamed, no need to turn on your cameras or mics if you don't want to. Your consent to be filmed was completed during the registration process. We're back in all this stuff again. So I'm sure you've seen this before. We're doing science, technology, engineering, math. We call that STEM. I'm sure we all remember that. Emphasis on the amazing part, right? If we remember what engineering is, anybody have any cool examples of engineering? Anyone's relatives work in engineering? I may have forgotten since last time, but I'm sure we've seen this every time, so we know what engineering is. Civil engineering, very cool, Nathan and Jason. So they would work on like buildings, bridges, the sort of structures and whatnot. As a software engineer. Welcome back, Nishi. Very cool. So we remember what engineering is, solving problems and whatnot. Yeah, yeah, perfect. We said it at the same time, Nathan and Jason. So we're talking about engineering and entertainment. So I think we may remember this from last time, but we're designing and solving problems for the scenic and the entertainment stages and whatnot. There's companies even in Toronto, I can remember only one of them right now, called Eventscape, and they make these amazing sort of structural pieces, these structural art pieces, using engineering principles and whatnot, to make these beautiful art pieces, and that's engineering and entertainment, right? So we can use all these fields like mechanical, material science, chemical, whatnot. Remember our design process, our goal is to sort of solve something. So first we have to identify what that is, what that problem is. Then we brainstorm our ideas for it. And then after we brainstorm, we design a solution. Then we make our model, and then we test and evaluate. And at any point, we can go back. We can go back and revisit these steps if need be. That is the power of the design process. So this is something that we looked at last time, zoetropes. We combine like zoo, which means like life and animal life, and trope and things that turn. So the the etymology is zoo trope, and in Greek it means wheel of life. It's an early form of animation. Remember this from last time. Today we're going to be looking at kaleidoscopes. So the sort of breakdown for that word is kalos, which means beautiful. Ido from eidos, which is shape, and scope is seeing. And that kind of roughly means observation of beautiful forms. So how do we get these pretty and repeating patterns? So if you look on the right there, this is what a kaleidoscope kind of looks like. And you'll see that there is some repeating. There are some reflective lines like along here and maybe along here and maybe along here. So how do we get these repeating patterns? That is our question for today. I'm going to leave that there. And I'm going to talk about a little bit more engineering and entertainment. We're going to talk about engineering and film. So one of the cool things that you can do with your engineering degree is you can go basically anywhere you want as an engineer. If you want to work in the film industry, you definitely can. There is something called a special effects engineer, which is just one example of engineering in film. And you can go into it with a mechanical or electrical degree, or even a software degree if you'd like, if you want to work in special effects and stuff like that. So the goal of a special effects engineer is to bridge the gap between film and reality. That's kind of the way that I thought about it. You have to make things seem real, right? While also like embellishing and flowering them and making them really nice to look at, and following the director's sort of vision, right? So you're bridging the gap between the realism and like the fantasy of film, and sometimes it's all realism, and you need to make it as realistic as possible. These special effects engineers would be responsible for explosions, making structures. They'd be responsible for the realism aspect of those things. They would be involved in consulting and definitely more things that you can think of, right? Like demolition and whatnot. So there was an interesting engineer I was listening to on YouTube talk about his engineering in the special effects sort of category, talking about making a planned sort of scale model of something and then having it collapse in a very predictable way. And they only get one shot, so the engineering they had to do was very precise. And as soon as the camera started rolling, they had one model. They could only take one shot of this because it's going to collapse, of course, and it's really hard to put it back together. So they take the shot and it collapses exactly as intended. And that's sort of the job as a special effects engineer. You can also work on things like mechatronics in film. If you look at this robot here, to get those very smooth, clean camera shots, right? Look at the way he sort of drags his arm, and the robot tries to mimic that action as smoothly as possible while still maintaining focus on that shoe, right? So that's a huge combination between mechanical, electrical, software engineering, mechatronics engineering, and stuff like that. So that is really cool. I think about engineering is you can basically go anywhere you like and experience different things. And I just put this little Batman sort of fire over here talking about special effects engineering because I really like the movie and it's a really good example of special effects engineering. We're talking about kaleidoscopes today, so it's obvious that we'd be talking a little bit about light and how light works and that sort of funny thing. So I'm going to try not to go too in depth into light. I could ramble on for hours about this, even though I'm not crazy. I'm not too advanced in physics, but I feel like light is really awesome. Yeah, white light and prisms. Light is a form of energy. If you've ever heard that before, if not, that's totally fine. We can describe light as like a form of energy. It is an electromagnetic radiation. And light will travel much, much, much faster than sound. So that's 300,000 kilometers per second, right? I've only ever taken my car, 100 kilometers an hour. think about how much faster light travels at 300 kilometers per second. And it's a good thing that light travels that fast, because if it didn't, it would make things really weird for us. But light is very fast. And the thing with light is it travels as a wave and straight beam. So it has this sort of duality. Once you get into high school physics, maybe you'll hear about that. The wave nature of light and the particle nature of light, where light will act as both. But I don't want to confuse you too much about that. Our friends, Nathan and Jason, mentioned white light. Yeah, very true. So this is a prism here. There's some white light that comes in, and then it gets split up into the different wavelengths of light. So red, orange, yellow, and in between, due to an effect called refraction. We're not going to take a look at refraction just yet. So this is light. White light is comprised of all the other wavelengths. That's why it splits up when it hits that, right? Really interesting. Refraction is the manipulation of light. Yeah, it is, like bending. We'll take a look at it in a second, Nathan and Jason. Very cool that you know that. Light is the fastest thing in the world, Joshua. Do you know why light is the fastest thing in the world? Or what allows light to be the fastest thing in the world? If you don't know, that's totally fine. I'll tell you.
Energy?
Did you say energy, Joshua?
Yeah.
Okay. You can turn your mic off now. Sorry, I'm just hearing the feedback. Okay, yeah. So yeah, energy. Light is energy. But the specific reason is because light has no mass, right? There is no kind of stuff making it up. It is just kind of pure energy. So you're right in that sense, Joshua. And that's what allows it to move so fast, and why nothing with mass, like humans or my pencil, because it has mass, it has stuff, it can't move as fast as light, because light has no mass. Did you want to say something, Joshua? Okay, all good. So let's talk about reflection for a second. Sorry if any of that went over your head. I told you I could talk about light for hours, but we'll talk a little bit more in the the visual sort of realistic sense of light, where we have things like reflection. So the law of reflection states that the angle of incidence and the angle of reflection are going to be equal. So what that means is when light heads to a smooth surface at an angle, the light is reflected off of the surface at an equal angle. Nathan and Jason, you guys are getting too advanced right now. Albert Einstein said, I think something about traveling in the speed of light can cause time travel. Depends. You think it's impossible though? That's a decent stance. Yeah. So the law of reflection states that this sort of interior angle here that you see in this triangle is always going to be equal to this sort of interior angle here for this sort of triangle that it makes here. If you have your mirror set up like this, right? So the ray that comes in bounces off your mirror, it's going to be equal. If you've ever shone a laser beam into a mirror, or even a flashlight into a mirror, and then you see the reflection behind you. I'm pointing over there because my mirror's over there. But you know, if I were to shine a laser beam into a mirror, that would be my hand, and it came in, it would come in and bounce directly off at the same angle that it came in, right? So even if I had turned my mirror like this, right, it would bounce off like that, right, based on the angle of incidence, right? And that just means the angle that I kind of shine it into the mirror, whether I go for a more shallow angle or a more steep angle, right, the reflected angle is going to react appropriately. Like reflection in geometry. Yeah, good analogy. Okay, we're going to talk about refraction really quickly. So refraction is the change in direction when light passes from one medium to another. Oh, that's okay. That's okay, Joshua. If you need a hand, let me know. I'll see what we can do. But refraction is just the change in direction when light passes from one medium to another. So if you've ever had something at the bottom of your cup, you can kind of experience refraction in this way, where you have like water in your cup and then you have some sort of material or like a penny or something, or a spoon when you put your spoon in a cup and it sort of bends and you see it bend. That's due to refraction, because the light that's coming off of the penny at the bottom of your cup, or the light that comes off the spoon in the water, it's going to bend. Sorry, I was thinking about your question. Nathan and Jason ask, does UV light count as a violet light? I would say no. Technically, violet light is part of the visible spectrum, right? So there is sort of ends of the spectrum that we cannot see, right, at both ends. Violet light is something that we refer to around like the sort of purple-ish sort of range of the visible light, but ultraviolet light exists outside of our visible spectrum. So I wouldn't think it would be counted. That's okay. And what is an example of red light? Red light is exactly what you think it is. It's just light that is has the wavelength of the red wavelength. Yeah, it's what you might be thinking of is like the heat or something. Don't worry too much about that. That's outside of our visible spectrum. So, oh, okay. So I see what you were talking about. You're asking this question: why red light bends the least while violet light bends the most. So you can kind of see in this sort of prism here that the red light doesn't bend as much as the blue light or the violet light at the bottom here, right? So the reason that is due to their wavelengths. And we can talk about that another time or another day when we get into the wavelengths of light and whatnot. But the reason that we have different colors of light, so like red, yellow, green, blue, is because they have different wavelengths. So the waves of light, they're like waves of water. Some of them are closer together, so they have like a faster wavelength, and some of them are longer and they have kind of like a slower wavelength. And refraction, right, is what happens when you pass a beam through a prism and you get this sort of thing, because the refraction is going to bend the light, right? So if you look at this GIF at the bottom here, we see the green light. Oops, I didn't want to do that. The green light comes in from the faster medium, which is air, into the slower medium, which is water, right? And you can see that it kind of bends in a way that we probably wouldn't expect. Uh-oh. Okay. So I think Joshua's computer is lagging a little bit right now. That's all good. Okay, so that's refraction, how the light bends when it changes medium, right? And it happens in a prism. Awesome. Okay, good to see. Good to see. That's what happens in a prism when it moves from the air to the glass, and then from the glass to the air, right? The light is going to bend the way that it travels, and that's why we get the refraction there, because of that change in medium. And the medium is just the material that's sort of the air is in, or sorry, the light is in. So that could be air, that could be glass and whatnot. Take a look at a kaleidoscope. So our goal today is to try to build one of these. So a kaleidoscope is an optical instrument with 2 or more reflecting surfaces, and the one we have here, we have 3. Right? We make up that triangle. And these angled mirrors are in a tube, right? So that it'll be reflected as the light comes down the tube. So patterns at the end of the tube that you would see, it's a see-through tube, would come in and be reflected and make this sort of symmetrical and like very illusion-y sort of picture inside, because the light comes in and then it bounces and it reflects a lot of different ways. A kaleidoscope will contain several mirrors placed at an angle to each other, usually 60 degrees, and this allows multiple reflections to be created of objects inside the kaleidoscope, right? So typically we have 3 mirrors, but you can go for more if you want some crazy pictures. You point your kaleidoscope towards a light source, right? This will illuminate the objects inside of your kaleidoscope. So in your end cap here, you would have some sort of objects, some translucent sort of objects at the bottom there. You want them to be kind of see-through. And then when your kaleidoscope is turned, right, it's going to make your items at the end of your kaleidoscope sort of tumble and move around. And this will create reflected images of varying colors and patterns and whatnot. Water has closer atoms, so maybe that's why light doesn't bend as much in air. You can kind of think of it like that, Nathan and Jason. Yeah. There is a more physicsy topic, but I can't explain that to you right now because that would make your mind go crazy. I promise. But ask me that question again at the end, and maybe I'll try to explain it to you why it happens. But it is a decent idea to think about like the density of the material, so how close the maybe the molecules are together. It's a decent way to think about it. So let's identify our problem. So we need to help the production designer find design patterns by creating a kaleidoscope. So that's our goal today. We are going to help a production designer find some really cool looking design patterns. And the way we're going to do that is making a kaleidoscope and then checking out the design patterns that we see in there. So what kind of pattern do you want to create? How many sort of reflective mirrors do you want? What kind of objects do you want to put in? That'll all affect the picture that you get at the end of your kaleidoscope. And I get a hand raised from Prapti.
What are translucent beads?
Okay, yeah. Translucent beads are sort of beads that you can partially see through, right? So if you think about something else that's translucent, like have you ever seen like tinted glass, right? Where you have glass where you can kind of see through it, but you can't see through too much through it. That's a translucent material because a little bit of light will get through, or some light will get through, but not all of it. Something like this cup would be transparent because all the light that goes through is just going to pass right through, and I can see through it very clearly. Right, so this is transparent, right? So the translucent beads you might use in sort of like artwork or clothing, right? These beads that you see at the bottom left here. I think these would be considered translucent, or we would call them translucent for our kaleidoscope reasons, because some light will pass through the center and what like that. If you don't have cardboard sheets, what you could do is, I don't know. I worked this one out with cardboard sheets. Maybe you could use your tin foil and sort of fold it a couple times until it gets like rigid. Maybe that would work. Speaking of my tin foil, okay, I got it over there. I gotta grab it for a second. So these are our materials that you might need, might not. if you don't have bands or beads. I think you need beads. Or just some sort of translucent material. I'm using some marbles as my sort of filler. So these are like kind of translucent. You can see through them. I can't see my camera right now, but if you can see these marbles, they're like kind of translucent. So that's what I'm going to be putting at the end of my kaleidoscope. Nicole gives a great solution. So if you don't have beads, you can try to use tissue paper, sequins, and stuff like that. Anything that you can kind of put at the end of your kaleidoscope and try to make it work. Okay. So these are the supplies that you may need. Think about the patterns that you want to create. Brainstorming a solution. Think about, why is light important for kaleidoscopes? And if you have an answer, feel free to put it in the chat, or if you don't, it's okay. I'm not really looking for anything crazy here, right? Just why is light important for a kaleidoscope? We'll think about that. And once you think about that, we're going to start making our model. So I don't want to run out of time, but I am going to switch over my cameras. Bounces off the object, then back to the eye quickly. Yeah, perfect answer, Nathan. So in this sense, it's not really bouncing off the object. It's kind of like bouncing, or it's passing through the object and then into our eye because we're holding it like this, right? But definitely, yeah, things that bounce off and then come into our eyes, how we see things. So yeah, perfect answer. Let me switch my cameras really quickly. Need to be able to see Zoom to do this. And while I'm doing this, if you have your stuff with you, right, try to cut out a clear piece of plastic that'll fit over your paper towel roll and secure it with tape. I will also be doing this. If I can find a way to see myself. Okay. Okay. Switch to my camera over here. That is on. Okay. As you can see my hands. What I'm going to do is cut some clear plastic that'll fit over my paper towel. Throw something inside. Over my paper towel roll. So what I'm going to use instead of some clear plastic, like a sheet of clear plastic, I'm going to use one of these translucent cups. I'm going to find how wide this needs to be and then cut out an appropriate size. So luckily for me, this is right at the edge of this circle. So there we go. So yeah, if you've got some clear plastic, like a sheet of clear plastic, trace over your paper towel roll, and then you'll get like a very nice shape that way. So here we go. Start cutting. Be careful if you're using like a plastic cup or scissors or whatnot, because this can get sharp. I'm trying to be as careful as possible. So cut off the bottom here of this cup, and now I'm going to clean up the edges because it is still pretty sharp. So I've got this piece here. No more sharp edges. Just going to try to make this uniform. That took a while, but I've got this nice looking piece that should fit right over my cardboard roll. And it's hard to see, which is a good thing. Right. Turn this glue on. Okay. And what we'll also need is we'll need a piece to fit inside of your paper towel roll. So we can do that in a second. Sorry, we're going to secure this with tape on for a quick second. If you don't want to, I think it might be a little bit easier to affix the one inside first, which is what I did. So if you want to, go ahead with step 2, or follow me to step 3 and 4. So we're going to cut out a piece that can fit inside our paper towel roll this time. So I have one that's inside already, but I'll go through the motions. All right, so here we go. And then if I wanted to, I could take a pen or some similar object and then trace on my cup where the inside of this paper towel roll should be. And I'll do that. Or using a pen, it would actually show up. All right, but I'm going to go through the motions of this. And then once again, plastic can be sharp. And your scissors are sharper. So right now I'm just cutting out a piece that'll fit inside my paper towel roll. So I've got a circular piece. It's really hard to see. Let me put it. I've got a circular piece that should fit on my floor. I'll pick this back up really quickly. Okay. A circular piece that should fit inside of my kaleidoscope nicely. It's perfect. So what I found easier is to affix this to the inside first, and then fill up your beads and then put the outside one. But either way is fine. So I'm going to do what I did here. All right. So inside piece comes in, boom. Get that locked in. I'm going to use some hot glue instead of tape. I got this part stuck in. Zoom out a little bit so you can see better. So just going to use some hot glue. I'll fix that to the inside basically, and that's what I've done so far. You can use tape if you'd like, anything to sort of affix that. I think I have it on autofocus. So I've got that to the inside. Now I'm going to put in my translucent material, which are my marbles. I can't fit all of them, so I'm just going to grab a couple of those in there. Okay, so I've got my marbles inside my tube, and my cap will go over. I've got a better cap over here. And then I'm just going to take my cap on. So I've got my marbles sandwiched between those two pieces. And I'm going to fix this sort of end cap on over here. So I'm going to be using hot glue again, but tape works just fine. Is anybody following along? If you don't have some materials like marbles or whatnot, you can just make as much as you can. And if you want to go out and buy some another time, that'll work as well. All right, just get like 80% of it done now, and then another 20%. I got my hot glue. So as this dries, my marbles will be sandwiched between those two pieces of plastic now. So if I turn this upside down, no marbles are going to spill out. If I turn it this way, no marbles are going to spill out. And this will dry completely in a couple more seconds. So now we've got sort of lens kind of thing here. Not a real lens. Okay. That's going to be it for our paper towel roll. Our next step is making the reflective surfaces. Is anybody following along? Are you doing okay? Say good. If it's challenging, you can just type it's a bit hard. Does the two plastic pieces have to be transparent? They can be translucent if you'd like. It might make it look a little bit weird, but that's the beauty of kaleidoscopes, right? We get these weird looking pictures. So it's okay if you choose to do it with a translucent piece or something, but you have to still be able to see through it. If you want, you can use a little bit of a darker piece of material that's still translucent and point it up towards like a light source, right? That'll allow a lot of light to get through. You don't have beads or marbles. That's okay, Malia and Malika. You could, or Meki. Micah, sorry. It's okay if you don't have the materials, you can just follow along with me, or you can just make sort of the outer structure, and then another time you can open it back up, put your marbles in once you get them, or your translucent beads, and use that instead. Okay, so that's what I've got so far. I'm going to move on to steps 5 and 6. Let's measure the distance from one end of the paper towel roll to another. So what I'm going to do is you can take your ruler, throw it down if it's long enough. Mine is not. So I have another roll that is much longer. Right, there we go. I just want to make sure that you all can see it. Right, so this roll goes all the way down. And I'm going to mark right here where the end of this roll is. So this distance here, from here up until a mark that I put, oops. So up until here, that is the length of my paper towel roll. You can use anything that's long enough to fit down the tube, or you can kind of just guess and see how that makes it. So on my cardboard sheet that I have, I'm going to measure out that distance. And there we go. On the ground for now. And then I'm going to cut 3 cardboard rectangles that are 1 inch in width and have the length of our paper towel roll. So we've got the length of your paper towel roll. Oh, you're on step 4, Prophecy? Okay. Take your time. Don't worry too much about it. I'll come back through this step and walk you through. Okay, so I'm just going to measure out the length. So this top line here is the length from the bottom. I'm going to try to take it a bit slower. Okay. What step is everybody on? 4. Okay, that's cool, Presley. If anybody else is following along, if not, that's okay. So if you're on step 4, Presley, right, your goal is just to sandwich the beads in between those 2 plastic pieces and have that encased with the tube. So here I've got my cardboard sheet with my lengths and my marks. So the way that I did it properly, was inside. I put my plastic circle inside. Okay, so I put it from here, and then I secured it on with some hot glue, but you can use tape, right? As long as you can get it around sort of inside here. So right at about this line, there's a plastic piece. all right, that I cut out from a cup, kind of like this, a little bit smaller than this. And I secured it in place right here. And then I put some marbles in to the end. And then I took another plastic piece, which looked like this. And then I secured it over the top. And then I used hot glue, but you can use tape again and just like tape around it. And then you'd have a plastic piece, some marbles, and then your end cap. All right, so plastic piece, throw some tape on the inside, whatnot. Throw some marbles inside, or sorry, I keep saying marbles, whatever you choose to use. It can be marbles, it can be translucent beads, it can be tissue paper, it can be sequins, anything that's sort of glittery or magical, like I'm not sure. And then your end cap, secured on by whatever you like. Not sure if you can do that. So I'm gonna cut out my cardboard sheets right now. Okay, so I measured out the length that I need. Sorry, my camera is like super zoomed in. I measured out the length that I need. Hopefully my hand can help the camera focus. Okay. Sorry about that. Okay. So there we go. I measured out the length of my cardboard piece, and then I put some marks at 1 inch, 2 inches, 3 inches, and I'm going to cut those out into rectangular sheets. So I don't have a ruler long enough. I have this, just a metal piece from a bathroom fan that I'm installing. There you go. So I'm not sure if you can see that. But now I've got cardboard piece 1 here, cardboard piece 2 here, and then cardboard piece 3 here. I'm going to cut those out. I can use my scissors, but I'm lucky enough to have an X-Acto knife. These are really sharp if you have one, and make sure you use a proper cutting surface to cut on if you do use one. And always ask your parents before using anything sharp like this, and maybe they can help you out. Oh, it is on slide 3-4. Thanks, Nathan and Jason. So I've kind of cut out pieces slightly. I'm going to get a better cut through them. separated that from the main sheet. Okay, got some cardboard pieces here. I'm just gonna take off the paint from this side, and I'll clean it up. We got about 10 minutes left. Clean up these sheets so I can put the aluminum foil around them. I've got my 1-inch cardboard strips. That'll just go on the inside like that. Is that right? Oh, you know what? I think I cut these the wrong way. I cut the short end of them instead of the long end, but that's okay. We'll just have a smaller kaleidoscope. I gotta grab some aluminum foil. With aluminum foil, you'll notice that there are two sides to it. There's a shiny side and there's a not so shiny side. We're going to use the shiny side. Sides of it. I'll cut off about this much. Hot glue to keep this in place. All right. That's piece one. So this will go inside my kaleidoscope. Act as surface one, and then we'll do 2 and 3. Okay, and that's 3. So now I've got 1, 2, and then oops, this is the wrong way. I'll put the shiny side so that it's inside, and the not so shiny side, or the nicer side facing in, and not so nice side facing out. And because we're kind of running out of time, I'm not going to fix those in place just yet. So I'm going to try to get the camera to focus here. I'm kind of blocking the light source with my hand right now. So if the camera could focus a little bit better, you'd be able to see that there is some sort of like reflective pattern going on the inside there. And that's due to these reflective surfaces on the inside, right? Bouncing that light around and making that reflection a little bit nicer. So that is the kaleidoscope. So tape your 3 rectangles, slide the triangle down, and then you've got your kaleidoscope. So I'm going to point that towards stronger light source. I think I can use my flashlight for that. We're rapidly approaching the 10 o'clock mark. That looks better. As nice as it's going to get for now. So the challenge that maybe you want to think about is how can you make other patterns inside of your kaleidoscope? And if it worked, awesome. If it didn't work, that's okay. And that's pretty much it. And there we go. Thank you so much for coming. Questions? We've got one from Nathan and Jason. These will be still recorded. I'm going to stop the recording in a second. If we don't get any questions, I'm going to stop the recording and the live stream.
Excuse me.
Yeah.
Can you go back 2 slides, please?
Sure.
Thank you.
No problem. Okay. So we're here now. If you were able to get it, I am going to stop the recording now and stop the live stream. Oh, no, that stopped my share.